Alright, so bi-weekly starts, weekly starts very soon. Weekly Contest 181. So I did bi-weekly this morning, and I made a video, a highly edited video, I sped it up, and then I explained everything afterwards, because I'm not good enough to be able to do everything fast in 20 minutes and explain it while I'm doing it. So I have to do the speeding up thing, but hopefully I won't have to speed up this one, because it'll be a short, 40 minutes, which is short for me, but probably won't happen. So, yeah. And I'm actually prepared this time. Not in terms of, being smart, but, having the equipment right. So, there's a bit of a delay between my clock and online clock, but, it always happens. So, let's go. This contest is going to be a great contest. Alright. $40 minutes for this. Let's go! Finally, this problem, this very terrible problem, we are finally done with it. And I'm going to take a small break before I explain the problems. Alright, so that was a very controversial contest, even though it wasn't really controversial. And I'm probably going to turn off the timer because it's no longer useful. Okay, so let's just open up all the problems and I will explain them. First, a summary of this contest. Yeah, not a good contest, because not a good contest. Okay, I solved the first 3 problems. I also solved the 4th problem, okay? So, yeah, I'm proud. And I didn't use any guess and check this time. So, yeah. Here, let's look at my stats. How many bugs? 5 bugs. Oh, I'm eating 25 minutes for that. Oh, God. Yeah, not a good contest. First problem was trivial. Second problem was, also trivial. Third problem was trivial but very much edge casey, and problem 4 was trivial, which is weird. Also, when I say trivial here, it's because I'm a mathematician, so I say trivial a lot. And okay, I'm sorry. It was easy. So, okay, problem 1. create target array in given order. This is basically just you're given an array of numbers and you're given an array of indices, and you have to keep inserting the numbers in the correct indices. And like Python has a library for this, so and like there's no off by one errors in the Python library, so it's pretty easy. We just do what we're given, and like that works. Okay, problem 2. 4 divisors. This was a weird problem, right? Wait, is that right? Is that? Yeah, okay, this is problem 2. So we're given an integer array of integers, and we have to find all the elements that have exactly 4 divisors, and then we have to sum up the divisors of those numbers. So there's nothing smart to this. There probably is a smart math way to do this, but I'm not that smart at math, so like I just did it the dumb way. Basically, to find if an integer has 4 divisors, we look for all the numbers up to its square root, and we see if there's any divisors in there. And there can only be exactly 1 divisor, because if there's 2, that would mean there's more that get paired off later. And we all know that numbers, and we know that factors come in pairs, 1 less than the square root of the number, and 1 greater than the square root of the number, and then they multiply to form that number, and that's what a divisor is. So we have to make sure there's only, okay, so if an integer has 4 divisors, it can be written as n equals pq, where p and q are primes, and they are distinct primes, because if they're the same prime, then they don't count as separate divisors. So these are called semi-primes with unique prime divisors. Yeah, and the reason I got a bug was because I didn't realize that they had to be distinct, and that's why I thought 4 was actually good. And I would have actually gotten that if I used the right test case, but I didn't, so yeah. Okay, basically, yeah, we take an integer, we look at all the numbers up to its square root, there has to be exactly 1, and then if there's exactly 1, then we sum it up with the other factor, and then we sum 1 plus n. And then otherwise we just return 0 if it has a different number than 4 divisors. Wow, that's a lot of submissions. Okay, yeah. So we just go through all the numbers and sum them up, because we've wrote our function to return 0 if it doesn't have 4 divisors. So yeah. Number 3, this is very infuriating. So okay, so we keep track of where we are, and currently we start at 0, 0. At first we start at 0, 0. And then we have a variable called argument, or you could also call it direction, but dir is like an already taken variable. So I used argument. And argument basically specifies what direction you're going in at first. So, oh no, I didn't explain. Okay, sorry, I didn't explain this problem, because like it's so stuck in my mind. Okay, so we're given an m by n grid, and each cell of the grid represents a street. The streets can be any of these 6 streets, and yeah, it's pretty intuitive. And you have to start at 0, 0, and then you have to go to the bottom right corner at m minus 1, n minus 1. And the path can only follow streets. But notice that you don't have to use up all the streets, and that is what cost me my final bug. So yeah, you're not allowed to change streets. You have to return true if there's a valid path, or false otherwise. So there's 6 kind of streets. Basically, what I do is specify an argument, and then specify where you are right now. And then the argument for street 1 starts at I used y-coordinate indexing, because that's how an array is structured normally in programming. And that's non-intuitive, but basically you specify the y-coordinate before the x-coordinate. Yeah, that's very weird. Okay, so street 1, you would start going in this direction. Wait, is that right? This direction? This direction, yeah. You would start going in this direction. Street 2, you would start going in this direction. Street 3, you would start going in this direction. Street 4, you would start going in this direction. Street 5, You can't, because it has to be either this way or this way, and Street 5 only goes that way or that way. And then Street 6, you start off in this direction. Notice that Street 4 has two possibilities for starting, either going down or to the right. So we have to consider that twice. So we write a function, write a big function that takes in the starting argument, because that's what we need for 4. And then because 4 has two possible starting arguments. And then we just basically keep track of where we are, find the neighbor, find the next block we're supposed to be at, and then compute the new argument. And then if anything fails, we return false. And oh, I am so lucky that didn't happen. I am so lucky that didn't happen. God. Okay. So, yeah, and it's a lot of code, and it's pretty tedious, and it took me a long time to write it, as you can probably see from before. And then before I verified that we traveled across all the blocks, but it turns out you don't actually need that. So you just verify that you go to the end, at the very end, the bottom right at the very end. And then, yeah, you find the starting arguments, and then 4 has two possible, 5 you just return 0, and then you return that. Okay, this is a very infuriating problem, because it's just very tedious. You have to code a lot of cases in. It's like doing casework in math. I don't like casework in math, and I don't like casework in programming either, unless it's like done automatically. Okay, problem 4, longest happy prefix. It's called, a given string has a number of prefixes, and it's called a happy prefix if it's a non-empty prefix, which is also a suffix, which means the string starts with that substring, and it also ends with that substring. Since the length of the string is not very long, it's only 10 to the 5, we don't have to binary search it, so we just loop through the entire thing, and then keep looking if the current prefix is does match the suffix, and if it does, then we increment it, and then we just return it at the end, which is like, yeah, I don't know what they were thinking about this contest. Like, seriously, problem 3. No, okay, what? How do you? Okay, that's pretty big brain. Doing problem 3 in like 8 minutes, like, so I don't know how people managed to solve all these without any bugs, like especially problem 3, because it took a lot of cases. Like, maybe they're just good or something. Like, I don't know. 700 it looks like. Yeah, somewhere around here. 752. There we go. I'll be ranked 752. It's already shown there. That's great. But like, I don't know what they were thinking for this. Oh wait, no, I have to look to see. Yeah, it looks like everybody solved 4 before 3 because 3 was just so infuriating. It looks like everyone got bugs on 3. Yeah. Okay, here's what I think they were doing for this contest. 1 and 2 were like short standard problems. Number 2 is math. I guess, kind of math. So, yeah. Number 1 was actually a very trivial problem. Like, if you're using Python, because you just literally use the insert function. Number 2, it requires a bit of thinking, yeah. Number 3, they wanted everyone to trip up and code all those cases, which is like, takes a lot of time, and like, they just put problem 4 in there when they finished 3. Like, I mean, like, it would really anger me if I had finished 3 and then I went to 4. But like, okay, so your ranking is only determined by like your total finish time, so it actually doesn't matter. And it looks like everyone solved it and the contest is over. So yeah, it's over now. Okay, so probably what I'm gonna do for this this video is I'm gonna speed it up and edit it again, because it took me a long time to do those problems. Yeah, it took me quite a long time, and you can see that this contest was an easier contest because like top 700 solved all 4. Like usually, if a contest is, well, actually, yeah, that's pretty true. Good contest, actually, it's a pretty bad contest. I think this is lower quality than what they usually do because it's less standard, you know. Problem 3 took too long. I just finished uploading my bi-weekly video, so please watch it. I will put a link in the description of this video, and thank you for watching. Goodbye.